breakthroughs in science and technology, innovations in business and beyond. Join us as we educate, enlighten, and entertain. This is Advancements.
Coming up next, watch as we explore some of the latest innovations helping to redefine the manufacturing sector.
The global electronics market is valued at over $1.3 trillion and continues to grow. As the backbone of society, responsible for powering essential services, advancing healthcare, and keeping the world connected, electronics support everything from consumer devices to critical infrastructure. Yet as these systems grow more sophisticated, they also become increasingly vulnerable.
Printed circuit boards were first developed back in the 1950s, 60s, where the components were formed and went through the board and soldered on the underside. Over the last 30 odd years, through-hole technology disappeared and the surface mount square components came into operation, but it's become more and more condensed. Therefore, any electronic device that you're carrying around with you into a cold environment is exposed to, say condensation. That's why conformal coatings have grown.
For more than half a century, the electronics industry has relied on protective coatings developed for early circuit boards and simpler devices. As technology advances, these legacy materials are struggling to keep pace. Meanwhile, performance limitations keep them from safeguarding the critical systems we rely upon daily.
Classic coatings of the last 70 odd years, when they're applied, often do not cover the sharp edges of the modern surface mount boards. And you may have to put 3 or 4 layers on. That could take time because the classic coatings can take 15-20 minutes to dry to handling before you can put it back through.
Leaving sections of a circuit board unprotected is problematic both at the factory and for end consumers like ourselves. At the factory, legacy conformal coatings cannot go on all of the components of a circuit board, and they'll put small pieces of tape on it or small pieces of material on it to mask it as keep out areas. Now, when the consumer gets that in an electronic device, if water gets into any of those masked areas which does not have coating on it, that device could fail.
To combat these challenges, the industry is starting to rethink protection from the ground up, focusing on revolutionary technologies that are both environmentally responsible and powerful enough to ensure reliability of modern electronics, all while keeping factory costs and demands in check.
It's been a very traditional process of putting gluey stuff that's toxic to humans on PCBA, the printed circuit board assembly. And many of them had isocyanates in them, and a lot of them have PFAS. What if we could have something that was safe for humans, that was non-toxic? What if we had something that went on the entire board, antenna, processor, connector, underneath the BGAs? What if we could have something that went on really fast? No cure time, just do it as fast as you can. Now we have something, you can take this board, submerge it underwater, and it works. So our innovation was really to overcome all those problems in the chain. We actually cover the entire board. So we envelop the board with our nano coating, and now you can submerge this PCB underwater. Notice how you can take your phone now and it can drop underwater and it doesn't fail, and it used to.
Most legacy technology are hard, cross-linked, lacquer-like coating. These coatings tend to trap heat, they tend to crack, and actnano's technology involves engineering our gel coatings to be elasto-viscoplastic. What that means is that the gel state coatings acts as a gel or a liquid when you want it to deform and when you want it to flow. But when you want it to be a durable hard coating, they essentially behave as a solid, offering the highest performance you can for protecting your electronics.
These next-generation coatings enable true, comprehensive coverage that protects electronics from water, humidity, and contaminants, while preserving performance and streamlining manufacturability.
In electronics manufacturing, they're looking for any bottleneck in that process that's going to cause them to lose out money. And coating can be that bottleneck. Our materials are meant to be dry by the time they leave the coating machine. It is one step. There is no curing, there is no oven, and our materials are meant to be a drop-in solution. So you can actually remove coating equipment, so you save on CapEx, you save on time, and you increase your overall throughput, sometimes 2 to 5 times faster than what a traditional conformal coating can do.
As the world becomes more connected, more automated, and more dependent on technology, new solutions are proving that manufacturers no longer have to choose between speed and reliability or performance and environmental responsibility.
Electronic products are getting more and more complex, and electronics are being used in more and more safety critical systems, and that is exponentially growing.
The next frontier is AI. These systems require liquid cooling to be able to run this hardware. They're being pushed to their limits, and even the biggest companies in the world have realized the advancements they've made on the digital front has outpaced what hardware can actually do from a reliability standpoint. They're running liquid cooling lines directly next to electronics. That's inherently dangerous. Liquid and electronics, high voltage, they don't mix. We've been doing this in automotive for over a decade. It's a very similar use case, and I think we should all be feeling safer knowing that these applications are being protected in a modern way.
If you put the right people together, if you have the right smart people working on smart things, you can almost solve any problem. Today we work on problems of the future.
Advances in cutting-edge coating technology are making electronics safer, greener, and more reliable than ever, protecting the future of global innovation while setting a new benchmark for the industry.